Rosemary Clooney's in it. All right, here we go. Not that anybody cares. We are going to review a little something, something. So today is the definite second month. There we go. Here we go. We are going to look at angle measures. Okay. And we're going to look at converting degrees to radians and radians to degrees. This is, I don't know why this is after the fact, after we've gone over this stuff, but it is. For the most part, you guys know if it's a special angle and it's on our unit circle, then you know that a 30-degree angle is equivalent to pi over 6, right? And we kind of showed that, we proved that, but how do we make the mathematical conversion, okay? This is how we're going to convert from degrees to radians. It's very simple, very simple. We know that 180 degrees is equal to what in terms of radians? It's equal to pi, okay? Now, if I wanted to find out how many degrees, how much 1 degree is equivalent to, and that's all I'm given, okay? I want to figure out what 1 degree is equal to. Mathematically, what could I do? Oh, how'd you do that? Oh. If I divide by 180, what I do to one side, I have to do the other. Then that gives me 1 degree is equal to, Smarty McFarty, yes, pi over 180, right? Very good. So that means this right here is your conversion factor. When we go degrees to radians. Okay? Degrees to radians. And think about it. That ought to be correct because when we go 1/2 of a revolution, 180 degrees is equal to 1 pi. So we're able to get to mathematically come up with that. 1 degree is equal to pi over 180. Now, mathematically, I want you to show me, I want you to convert 30 degrees into how many radians? We already know this. We know this, but what if you had to prove it? Here's what I would do. And I hate making conversions. I cannot stand it. A factor is something that we multiply, okay? What is our conversion factor? Pi over 180. And I want you to notice something. Look what's on the diagonal. Our degrees, that's on the diagonal, right? So now we're able to cancel those out. And now we're in terms of radians. And can I also cross-cancel the 30 and the 180? Yeah, 30 goes into 30 one time, 30 goes into 180 6 times. And when you multiply straight across, it gives us pi over 6, which we already knew was our answer, correct? We already knew that. But mathematically, that's how we come up with this. Because you know I'm not going to give you these easy angles. I'm going to give you some wild, crazy angles that you've got to convert. Now, check this one out. I want you to prove, we already know the answer to this. But I want you to prove what 45 degrees, how to get what that is as radians. Bless you. It's kind of delayed reaction. We already know that it's what? Even without having to prove it, we already know that 45-degree angle is equivalent to how many radians? Pi over 4. I know that, but how do I show it? So I take 45 degrees over 1, and I'm going to multiply it by what? Pi over 180. My degrees is on the diagonal because that's what I want to have to cancel out. How many times is 45 going to 45? Once. How many times is 45 going to 180? 4 times. Oh, yeah, look at there. Indeed, pi over 4. This is when your math frac buttons, because some of you are like, I don't know what you're doing cross canceling. I don't want to think that much. So this is when you use your math frac button on your calculator. Does everybody understand how to do that? Okay? That's the lazy man's way, but it works. And I will. How about this one then? I want you to convert 18 degrees, and then I want you to convert 240 degrees. And then I want you to convert one more. Conversion factor, 18 degrees. I'm multiplying by, here's my thing. I know that I want to cancel out what? I want my degrees to cancel, so I've got to put 180 degrees on the bottom, which means pi has to go on top. This way I don't have to think about it. 18 degrees goes into 1, 18 degrees goes into 180 how many times? Folks, did you get pi over 10 for the first one? How many of you hands up? Rock on. How about the next one? Same conversion factor, right? Now this one, you may not want to figure, I don't want to make my head hurt. But, and Megan's like, that's right, I don't want to. Did you just multiply and get 240 divided by 180 in math bracket? What did you end up getting? 4 over 3? Hang on, I'll get it. How many of you had 4 pi over 3, folks? Hands up. Cool. And then what about the negative? What do you have to be sure you don't do here? Don't ignore the negative sign. Don't forget it in your answer. $135 and 180 are cross. We can cross cancel those by using 45. 2, 3. Is this 4? No, this is 3, isn't it? I don't want the degrees. 3 and then 4 here. So did you end up getting negative 3 pi over 4? How else could we check this just to verify that we're right? Especially that with these that end up with a pi over 3 angle or a pi over 4 angle or a pi over 6 angle. Go back to your unit circle. Check it. That's why we spend a lot of time on that. Okay? Use it. Questions at all? Fractions, 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 never, never decimals. When we're dealing with radians, right? 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 Yep. Okay, here we go. It's seen it go. Okay. Twist. All right, so look at this problem. A little bit different. 5. Let's just do it all here on the same page. Shoot. All right, this one's got a little bit of a twist to it, okay? Because look what what's your, look what you're given. I know what you're given. Oh. let's go this way. I had the page turn. I was thinking we hadn't gone over that yet. All right, so let's look at this. Now, we were going from degrees to radians. Now we're going to go radians to degrees. And there is a little twist. If the conversion factor is pi over 180 from earlier, okay, we were given degrees, we used pi over 180. Now we're going to be given radians. What do you think the conversion factor is going to be this time? It's going to be 180 over pi. It's just flipped over. Now, here's what I want you to remember. Pi is equal to 180 degrees, which means if we did the same thing that we did earlier, and we divide, because we want to find out how many radians, then we're going to divide pi into both sides, and we find out that 1 radian is equal to 180 divided by pi. That's your conversion factor, this right here, okay? Four radians to degrees. And what's real important to me is recognizing what I start with. That way I always know what has to be on the diagonal, and it cancels everything out. Now, you already know the answer to this, but we've got to prove it. If I were to give you pi over 3 and you had to determine how many degrees, we already know the answer. What's the answer to this? Thank you. It is 60 degrees. You already know this. But how would I show it? Look what's going to happen. What's going to cancel out now? The pi, okay? If you start with pi on the top, you've got to have pi on the diagonal, because I want those to cancel out. And now we're in terms of degrees. 3 goes into 3 one time, 3 goes into 180 60 times, and what's the answer? 60 degrees. We just showed that we knew what the answer was. We just verified, okay, that pi over 3 is 60 degrees. Let's go with this. I don't want to have to think about this. But what if I ask you to show the conversion? Pi is equal to how many degrees? What would we do? Pi over what? Pi over 1. This is pi over 1 times who? What must be on the diagonal? What's the conversion factor, folks? 180 over pi. So what has to be on the diagonal? Pi does. So they will cancel out. Hello. 180 divided by 1 is what? 180. That's just showing, proving how to make that conversion. How about this one? Any questions at all? Do you think this is easy? Yeah. It is easy. Pardon me? This is all you have to do for conversions. It is. Do what? No. No. A little bit. A little bit more. -7 pi over 6. Convert that. When I look at this, I don't even think, what's the correct conversion factor? I think, what do I have to have on the diagonal so it will cancel out? Pi. So what is my conversion? That leads me to my conversion factor, which is 180 over pi. Does that make sense? This is just something else I don't have to memorize. I'm thinking, what can I cancel out? The pi's cancel. The 6 cross cancels. What is negative 7 times 30? Negative 210 degrees. How many of you got negative 210 degrees? Do you have questions? If you didn't raise your hand, is it because you did not get it? Did you not understand? Or did you just not feel like raising your hand? Or a combination of all three? The last one, thank you for your honesty. Okay? It's all right. Here's the twist. Here's the twist. This is what I was looking at going, we hadn't done this already. What if it's in terms of real numbers? There is no pi. Oh, what does Miss Perry do now that she doesn't have a pi and she's got to remember, oh crap, what do I have to have on the diagonals? This is what I have to do. I know that radians are always in terms of pi, right? So in my head, I'm going, okay, 5 radians over 1. If I have radians on the top, what do I have to have in that diagonal? Radians, which is pi. That's my clue. I connect radians to pi, pi to radians. So that means 180 has to be in the numerator. And now what? Does anything cancel out now? Nope. So what do I do? Harky, what do I do? Multiply across. 5 times 180, is that 900? I just made that up. Yeah, it is 900. 900 over pi. So we're really going to put 900 over pi degrees. Aspen, are we really going to put that? What do you think? You guess? John Paul's going, no, I don't think so. What should we do? Hey, guys, what do you have attached to your hand? Or you should have attached to your hand every day in this class? Calculadora. Get your calculator. We're going to calculate this 900 divided by not 3.14. I literally want you to divide by the pi button. Does everybody know where the pi button is? Where is it, Debbie? Oh, yeah, it's right under the clear. It's the caret button. If you hit second, the caret button, that's what it's called, the little tent. What do you get? What do you get? All right, let's round this to the nearest hundredths. 286.48. Do you guys agree with that? 286.48 degrees. Cool? Cool with that? I have to share this with y'all. I just thought about it. There you go. You can share that with your parents. Some of you are still thinking about it. You just keep thinking on that. Here we go. You can tell Mr. Daddy. Mr. Daddy. Okay. Just to recap. If you start with degrees on top, you have to have degrees on the denominator. Okay? This is what we're looking for right there. Make sure the degrees is on the diagonal. Make sure whatever you're trying to find is on the diagonal. The diagonal is what's important. And then if we were going radians to degrees, then we would have something like pi over 7. We have graphed those, and y'all kind of look at me like I'm crazy. You go, why are we going to do this? Well, because what if you had to convert it? Then what are you going to put on the bottom? Pi automatically goes on the bottom. The conversion factor doesn't change. Okay? The diagonal is what's important. The diagonal is important because it helps us determine which conversion factor to use. Okay? I'm going to think about that joke all day. It's going to make me smile. I think it's so cute. All righty? Questions at all? The diagonal is what's important. That's what's important to me because it helps me determine which conversion factor to use. All right. Now, getting ready to change gears a little bit. Now, let's think about, ready? Coterminal angles, changing gears, completely changing gears. Coterminal angles. I told you on Thursday and Friday when some of you said, what's equidistant mean? I said, use your context clues. Use your English skills to figure out what that word means. Equidistant means what? Equal distance. Use your context clues. Coterminal. If you have a terminal side of an angle, what does terminal mean? Where it ends. What does co mean? Along with. So this could be a couple of angles that end along with each other. They end, how could I make that better? I could say that a better way by saying two angles who share the same terminal side. They share the same terminal side. Why would this occur in the angles that we've been graphing? Think about how this could occur. Oh, I could have a positive angle rotation. I could have a negative angle rotation. And they could still end at the same place. How about this? If we were to have angles have an initial side, which is where? Where's the initial side of every angle on the unit circle? It is 0 degrees, okay? The initial side of every angle we graph thus far has been at 0 degrees. Where we graph it, where it stops, is the terminal side, okay? And it can stop, it doesn't matter whether it's a positive or negative, wherever it stops, that's the terminal side. Now, if you had to determine whether two angles are coterminal, let's look at these two angles. Let's look at 40 degrees and 400 degrees. Now, what do you know I'm going to do? You know what I am going to do. I'm going to draw a picture because I can't do it without it. I can, I just don't like to. I like to see it. Which quadrant will 40 degrees terminate? First quadrant. So there's my 40-degree angle. What the world? What's up with the 400-degree angle? It's going to go all the way around and do what? And go back to the same place because 40 degrees is just 40 degrees, but 400 degrees is one revolution plus how much? 40. Ah. So you might go 360 plus that little piece. Do they share a terminal side? Yeah, they share a terminal side because they end at the same spot. So are these two angles coterminal, yes or no? They are coterminal. No. Mathematically, what's important to us? That they end at the same place. 360 degrees will be important to us. Sometimes it's going to be in terms of radians, so 360 is not going to be important to us. What's going to be important to us? 2 pi, okay? Remember that. How about this one? I want you to determine whether these are coterminal. Negative 40 degrees and 320 degrees. Determine, show whether it's with a picture or mathematically that they are coterminal or not. On your paper. What do you know I'm going to do? You know I'm going to draw it. I have to draw it. So when I draw negative 40, I'm going to rotate which way? Down. There's my negative 40 degree angle. What am I going to do for my 320? I'm going to draw my rotation up, but heck, it's going to land where? Same place. Same place. Are they coterminal, yes or no? Yeah. Mathematically, how could I do this? They are coterminal. All right, based on my picture. Say it again. 360 minus 40. 1 revolution minus, or add, it's actually adding the angle we're given plus the given angle determines whether they are going to be coterminal or not. Correct? Yeah? Questions at all? All right, here's what you're going to do, because I want to be sure you have time to start on homework. God, this is so easy. Yeah. Here we go. Here's what I want you to do. Look at page 184. All right, guys, here we go. I want you to do 1 through 6. Nine through 14. 23 and 26. Okay. As far as conversions go, that's going to be easy. 23 and 26 has to do with whether the angles are coterminal or not. You can feasibly finish this before you leave today. Okay? Get it done.